Good morning, students. Welcome to the class. We were discussing palladium catalyzed coupling reactions. In this class, we will discuss Negishi coupling. What is Negishi coupling? Negishi coupling is the coupling of unsaturated organo-zinc, organo-aluminium, organo-zirconium reagents with alkynyl aryl and alkynyl halides using palladium catalyst. So in the previous case, where we have discussed about Heck reaction, one of them is alkynyl or aryl halide, other one is alkene. But here we are using organometallic reagent instead of alkene. Now, in this case, this is an organometallic reagent and it will couple with an alkynyl or aryl or alkynyl halide. In Heck reaction, it is just alkene. So the stereochemical outcome of the product depends on the transition state. But here, this is not an alkene, this is a organometallic reagent. So here we don't need to look for the stereochemical outcome of the product. The stereochemistry of this carbon organometallic reagent, carbon transition metal bond will retain. Similarly, the stereochemistry of this carbon halogen bond will retain. That means we don't need to change the stereochemistry of this. You just replace this ZnCl and iodide and couple with these two, this carbon and this carbon here. Okay. So you just make them couple. You just remove this. So don't change this bond. This bond should be like this, like E. Here also don't change this bond stereochemistry. Then what is the product? The writing product for all coupling reactions is a very simple task. Here we have triple bond NC4H9. So you don't need to worry about the stereochemical outcome of the reaction. Just remove this reactive part on both the substrates and just couple them. Don't change the stereochemistry of either this bond or this bond. Just make a coupling. That's it. Okay. So in this case, except Heck coupling reactions, all other coupling reactions, they are very easy to predict the product. I'll give you some more examples. What you can do, you can take notes along with me to save some time. Now, how do we prepare these organometallic reagents? Of course, we know some methods, but I will also discuss some other methods. When we reduce triple bond with dibal H, hydroalumination takes place. That means one side hydrogen will add, other side aluminium will add hydrogen and aluminium. So this is hydroalumination. So we have our reagent or substrate for Negishi coupling, organo aluminum compound. Then we can couple it with an alkynyl halide as I said, when we reduce triple bond with dibial H, we will get both hydrogen and aluminum on the same side, or we can say it is E double bond. When you want to write the product, what we need to do, you just remove this part Similarly, you just remove this part, then make a coupling between these two. So the product will be, this is the stereochemistry of carbon aluminum bond, it will be retained. Then this is the carbon iodine bond stereochemistry, it will be retained. So the product will be this one. So this is an example for hydroalumination of triple bonds. One side we have added hydrogen, other side we have added aluminum. Now I will give you an example for carboalumination. That means one side we can add carbon, other side we can add aluminum. So in this case, we will add methyl here, we will add aluminum here. So this is an example for carboalumination. Triple bond is now converted to alkene by adding methyl group on one side, aluminum on the other side. Then coupling with this allyl chloride, then coupling with this allyl chloride will give us, as I said, don't change the stereochemistry of this bond. Similarly, stereochemistry of this bond. So it gives both methyl and aluminum are same side, so that this bond and this bond methyl are on same side, and we have double bond like this. You just check the product. This is dicyclopentadienyl zirconium hydride chloride. This is used for generating alkynyl zirconium reagents. So hydrogen will be adding from one side, zirconium will add from other side. Mostly zirconium will add to less substituted carbon. So the major product is the zirconium addition onto the less substituted carbon. Then I hope I don't need to give the product. So you can practice these problems. So what will you do for writing the product? You just remove this part. Similarly, you just remove this part, then couple these two. Just couple these two, as this is E and it is also trans to CO2 Me. So this halide is trans to CO2 Me. So the stereochemistry must be maintained. I'll give you some more practice problems on Negishi coupling. So this is aryl halide and this is aryl zinc. Take these problems and predict the product. What is the product here? To write the product, what we need to do? Just remove this moiety and remove this halogen and just couple both of them. What is the product here? So here also what we need to do? Just remove this moiety and this moiety, couple both of them. This reagent, it is called as Schwarz reagent. It is used for hydrozirconation. So with the syn addition, one side hydrogen will add, other side zirconium will add. Yeah, generally zirconium will add to less substituted carbon. So this is 84% and zirconium addition on more substituted carbon. So hydrogen here, zirconium here, it is just 16% only. That means most of the time zirconation, hydrozirconation, zirconium adds on the less substituted carbon or less sterically crowded carbon. Yeah, because we have a methyl group here, so both sides we have a substitution. So in this case methyl is less sterically crowded, so zirconium addition will always takes place on less substituted or less crowded carbon. Alcohol is protected as THP ether. This is propargyl alcohol which is protected as THP ether. What is the product here? So organozinc hydrozirconation takes place, hydrogen adds here, zirconium adds here, that will couple with this reagent. In this case, the product is ethyl. It will couple with the aromatic system. Now, this reaction, I'll explain a little bit uh, about the additional co-catalyst. Generally, we use zinc chloride or zinc bromide as the co-catalyst in Negishi reactions. You know, without zinc chloride, after 1 week, this reaction has resulted in less than 1% product. But with zinc chloride, just within 1 hour, it has given 88% yield. So that means sometimes Negishi coupling reactions may not work. So that time what we need to do, we need to add an additional co-catalyst, either zinc chloride or zinc bromide. What they will do, they will just increase the rate of the reaction, rate and yield. They just increase the rate and yield of the reactions. So it is always suggestible to use a co-catalyst like zinc chloride or zinc bromide to increase the yield and rate of the reaction.